I've got a circle. It has a center, an angle made by connecting that center to 2 points on the circle. This is called a central angle. And the rule here is the measure of that central angle equals the measure of the arc it cuts off. So if the measure of that central angle is 40, that means the measure of that arc is also 40 and vice versa. Okay, next type. This type of angle is called inscribed. It does not start at the center. It starts on a third point on the circle. And so it is inscribed. And the rule is the inscribed angle is 1/2 the measure of the arc it cuts off. So if we imagine this was our same 40-degree arc, that means our inscribed angle is 20 degrees. And any angle inscribed in the same arc will have the same measure. So for example, if I take this point on the circle and connect it to our same 40-degree arc, it will also be 20 degrees. And by that same token, if I cut my circle with a diagonal so that I have a semicircle, this angle right here is 180 degrees. And that means that any angle inscribed in a semicircle will be a 90-degree angle. It will be 1/2 of the central angle. So if on a test, your teacher gives you that information, that teacher is telling you that this is a right triangle. Okay, next up, if I have two intersecting chords, then if I take a look at one of these angles, I call that angle X, then the measure of angle X is found by looking at the two arcs cut off by X and its vertical angle X, summing those and dividing by 2. So for example, if I call this arc A and I call this arc B, then the value of angle X is found by summing A plus B over 2. And the same thing would be true if I wanted to know the value of this. It would be summing this plus this over 2. Okay, next. If I have two chords and they are congruent in the same circle, then the arcs they cut off will also be congruent. So that's important to note. And then that, of course, also means the central angles will be congruent. So that's a lot of information just from knowing that two chords are congruent. Okay, next. So here I have an external point. And then here, from this external point, I have two lines that cut all the way through the circle, and we call those secants. So when I have a circle intersected by two secants that meet at a common external point, then I can find the value of this angle, this time by subtracting the smaller arc from the bigger arc and dividing by 2. So that's summarized like this. Okay, next. This time I have a secant and I have a tangent. A tangent means a line that hits the circle in exactly one point, exact same formula as secant. The value of angle X is found by subtracting the smaller of the intersected arcs from the larger of the intersected arcs. Okay, almost done. This time I have two tangents. Okay, I know a couple of things. First, if I connect the center to the points of tangency and then connect those to my external point of these two tangents, I have created a kite. So to remind you, a kite is a figure where we have two pairs of consecutive congruent sides. So my radii are congruent, and the distance from my external point to a tangent on one side of the circle and a tangent on the other side of the circle will also be congruent. Okay, other things I know. When tangents intersect radii, they do that at right angles. And then the last thing that I know is that when I intersect an arc from a point with two tangents, the value of this angle and the value of this intersected arc will be supplementary. They'll add up to 180 degrees. So to summarize, let's say we have a problem that tells us that this is 110 degrees, this arc is 60 degrees, and it wants to know the value of this arc over here, x. All right, I see that I have intersecting chords, so I know that this plus this over 2 equals this. And then I know I can find this by saying, okay, well, this whole thing is 180 degrees, so this is 180 minus 110. So that part equals 70, and now I can set up my equation. 70 degrees equals 60 degrees plus x degrees over 2. Multiply by 2, subtract 60 from both sides, and I find out the value of x is 80 degrees. All right, so that's how to use something like that. Let's take a look at another example. So let's say I'm looking at this picture. I want to know the value of x over here. So I see this is a tangent and a secant. So I know my tangent secant formula says that I take this and I subtract this and divide by 2. I've been given this 60, so I need to find this. So now I need to look at what else I was given in the problem. I was given 50 this, which is inscribed in those same 2 points. So the inscribed angle is 1/2 of the arc or central angle. That means this is 100. And now I have what I need to find x. 100 minus 60 over 2, 40 over 2, x equals 20 degrees. Okay, good. One more. All right, I have been given that this is 220 degrees. I want to know the value of x. I know that all the way around a circle is 360 degrees. So this leftover part would be 360 minus 220, and then I know that x and this are supplementary. That means they add up to 180, which means x has to equal 40. And then let's say I take it one step further and I have my center here and I want to know the value of my central angle. Well, there are 2 ways to do this. The easiest is a central angle is the same as its arc. So that means that that has to be 140. And then I can check and make sure that everything's right because I know these 2 over here are 90 degrees. So 90 and 90 plus 140 and 40 indeed add up to the 360 degrees that a quadrilateral ought to. All right, so that's a lot of information. There are some examples of how to play with it. Stay tuned for some videos with a few more finer points here. We'll take a look at chord segment relations to each other. We'll take a look at inscribed quadrilaterals, cyclic quadrilaterals they're called, and then we'll look at some problems that put it all together. But consider subscribing to my channel so you know when I put out a new video, and as always, keep on mathing.